Hey guys, Chris here. So I started this video on the modifications I'm making to my machine shop and the new mill, and also the lead screw, electronic lead screw, which I'm very excited about. So I told you guys I showed you what I had done so far, and that I was getting the Clough 42 set, and I'm looking for information on it online, and I haven't really found a whole lot on assembly and stuff. So I'm in the middle of doing it. I decided to start recording it because I couldn't find much on it. But also I'll show you, I got several different stepper motors and then 3 different encoders. The one that came with that other kit. And then I got this one because I guess this is the one that the guy, James from Clough 42 actually used. It's 1,024 pulses per revolution, but I got a 2,000 pulse per revolution. That's even higher resolution than this. So I think I'm going to probably use that. But I mean, I don't know. I got to see how the configuration works out. And then also, so the one I decided to get, I also ordered a servo motor, the one that he used as well. But the servo motor that I chose, this is the servo driver. And then the servo motor that I chose is this monster right here. This is a NEMA 34 sized servo motor, closed loop servo motor that goes to that driver. So this is massive. This is a big freaking servo. It's 156 millimeter. This is 12 nanometer, 1,700 inch pounds or ounce inch of torque. And I'll show you the integrated driver servo that he used. I think I'll probably stick with the encoder that I already got. I ordered those 2 after the one that came with that other kit. And then I'm soldering right now the boards that came, the Clough 42 board. And then I have the Texas Instrument board right here, the launch board already right here. So I'll show you what I'm doing here. Try to zoom in a little bit. All right. So this is the board, right? Well, so I already assembled the interface, and that's how that goes together. And then this is the other board that goes to the launch pad. This is the launch board, the Texas Instruments launch board. So I've got that ready to go. I 3D printed a mount for it, and I'm just soldering the remaining pins. I've already done the servo connection, the power connection, the 5-pin header, and then I'm doing the one of the 2 looks like 12-pin headers, 2, 4, 6, 8, 10, 12, 14, 16, 18, no, 20-pin. I'm doing the second one, the first one right now. I only have a few spots left. You can see in the microscope what I'm doing. I just have 3 pins left, and then I'm going to do the second one, and this will be done. So I'm pretty close. And I'm excited to get this on there and see how it works. I know I still have to flash the firmware, which is open source. It's on his GitHub. Here I go bridging it. This is the first one I bridged. As soon as I'm on the camera, of course, I bridge it. No biggie. I do have a soldering vacuum if I needed it, but I won't need it. It's not very hard to fix that. My eyes are not bad enough to need the microscope to solder, but I do check my work on it to make sure that it's dead right, up close and personal. A little bit off in there, a little too much. Matter of fact, I might just clean these up a little bit with the desoldering vacuum. So now I'm going to, the way I did it when I put the other one on, when I first started putting it on, so I used the flux pen and I fluxed both sides of this. For some of the bigger ones, I used this kind of flux, but for these headers, this was plenty, because I'm doing both sides, so it sucks it right through. And then I use this little clamp that I have to hold this in. So I'll just put this through. And this is just a typical cheap, you know, AliExpress or Amazon, you know, PCB vise. So I'll just clamp that down just until I get a few of them soldered. And let's get it out of the way of the pins so they can clamp it all the way down. Okay. Well, that ain't working very well this time. I don't know what I did differently last time. Oh, that's what I was doing. It went the other way. Now, the bottom part of this is longer than the top, so obviously that works better. There we go. Alright, so now I can get the first few soldered, and then once I get the first few soldered, I can move that. And this is an autofocus microscope. And it's 4K, so you guys should get it. Actually, they're not that expensive, man. These things are like $200 now. So anyways, I'm gonna start soldering this side. There we go. Now it's in there all the way, nice and tight. And those are the two joints I just did. And this light down. There's a little reflection from it. Okay, that soldering vacuum will beep when it's ready. And then what I do after I do a soldering like this, I'll clean it with alcohol, and then I use soldering varnish to cover the contacts so that they don't touch anything else. Not that I think they will, because I'll have this all mounted in a closed box with the power supply and the stepper, the servo driver and the Texas Instrument board. But I'm going to varnish it anyway. I do it on all my MCUs for the 3D printers. Oh, and sorry, this is the servo that I was mentioning before. This is this integrated driver servo that James from Clough 42 uses, and the torque on this versus the torque on that is a dramatic difference. I mean, obviously, look at the size difference, but I don't know. I mean, if this, the guy designed it, and I know he did some thorough testing with motors, so if this is sufficient, then I'm sure I can find another application to use that other servo for. Just give me another reason to find another project. But anyways, let me finish getting this soldered. Get it all nice and cleaned up, and then get it varnished, and then we'll get it put together, and I'll try to figure out how to get it flashed, and then I'll bring you back once I figure it out, and I'll show you how to do it. Come on, take it, baby. Oh, there we go. Let me try to bring this up a little more. Where's my knob? Oh, it's this all the way up. Okay, those are coming out nice and clean on this side. That's how they were coming out. I don't know if it was because I turned on the camera. I mean, obviously the camera's on now, so it's not affecting me. I don't think that was it. Maybe I just came back to it, and it's because I stopped for a minute. I don't know. I'm usually pretty good at soldering, even micro soldering, which this is small soldering, but it's not micro soldering. Let me get my precision tweezers and hold this solder for me. Hey, sorry about that, guys. I don't know why this Sennheiser transmitter, the battery dies so much sooner than the receiver, and I've got lithium-ion AA rechargeable batteries in here, so they last much longer than the nickel metal hydride ones. But anyways, they die in the transmitter faster than the receiver, so I didn't realize I didn't have sound for a minute there. So at the end, I was just saying, you know, this is the servo that he used, and I have the mount for it. You probably already saw it, and I have a new mount for the 34 NEMA 34 step servo motor size servo motor. If I decide to use that, I have to make that decision. But I'm going to finish doing the research and get the literature out of my big shop. Finish figuring out how to set this up, wire it, and get all that stuff squared away. Hopefully, I can get this operational today and get it flashed and all that. But you know, if not, then I'll bring you back when I do, but hopefully I can. So we'll see. I will bring you back either way and let you know how it goes. Oh, and also I have the DRO for the mill coming in today. So I did put the motion automated system on the Z-axis and the X-axis are both working great. And I actually got some controllers for the motion system. I'm going to have these operate it. So that'll be left and right, and then I'll have one facing this way to go up and down. Yeah, I already am making two housings for them. One is going to go this way to go up and down for Z, and one is going to go this way to go left and right for X. Y, I'm just going to crank. I'm not going to bother with Y because it's a short distance. The only reason I did X is because it's so long, and it takes so long to crank it. And when you power feed when you're cutting, it just makes a smoother cut. And you know, I put a NEMA 34 on that. That was somebody else. I'm gonna attach the link to that guy's video. It's really, he doesn't describe anything. He just shows it working, which you'll see in this video too. But it's his design. So you know, he obviously deserves the credit, and he shared the file. So if any of you guys want to make it for the same mill, then you know, he shared it on printables. So I'll attach that stuff to this video for sure. Okay, I'll see you guys in a little while. I'll let you know how I make out. Oh, and then also I got the DRO coming in today. Actually, I ended up ordering a 2-axis, and because I ordered a new Quill DRO because mine seems to be pretty steady, but I've seen other people have them not be steady. So I was going to make a new mounting bracket for the Quill DRO and put the new Quill DRO. So I'm gonna still do that, and that's why I only ordered a 2-axis. But as it turns, I ordered a nice LCD DRO, so I'm gonna put that one on my lathe, and I got a 3-axis DRO. They're actually fairly cheap. I got one for like $2 something, and the 3-axis for $300 on eBay. So with a nice LCD, and they have a lot of functionality as far as like, you know, making circles, and which I did get a rotary table, but anyways, it's going to be very useful for a lot of other things anyway, because after using the CNC mill as a manual mill for a while, I'm very used to having a DRO. So that's always something I planned on doing. But paying, you know, $900 from Precision Matthews versus $300 and installing it myself, it's not going to take me more than a few hours to install. I already did one on the lathe, which was harder than a mill. So I'm sure it shouldn't be too bad. But the lathe already has the scales on it. It's just this. I'm just going to use the screen for that. But anyways, today I think the one that's coming is the 2-axis. So that's going to be for the lathe. So I won't be able to get the mill one in until probably the end of the week. But I was thinking it was for the mill, but it's not. But anyways, I will bring you guys back when I figure out what's going on with this and what I can get done today and what I can't, and I'll let you know, and we'll take it from there. I'm actually going to go back in my shop real quick to grab my the literature on that. So I'll show you real quick how I made out with the X-axis from the guy's design that he uploaded attached to his video. And I'm going to link that video in the description here, so you guys can go ahead and print it for yourselves if you would like, which I highly recommend it if you have this mill and you want to. I mean, honestly, it's not a very big investment. You can get a small NEMA 34, like I did here. So here's the NEMA 34. And I had a bigger one on it, but because my welder's right here, which I still need to move over, I moved it over a little bit. Oh, and then I have this controlling the Z right now because I was testing it. And then but this controller right here, this controller you can buy, and you don't need to buy another stepper driver. This has 2 boards in it, and the back board acts as a step. It is a stepper driver. So it can't drive it with a crazy amount of power, but for this application, you don't need a lot of power. This is a low power application. So, I mean, all you're doing is moving the X back and forth. So it's a really low application, low power application. And then while I'm doing this, I'll show, this is the box that I'm gonna be using for all the stuff for the lathe. I'm going to be using this box right here. I'm going to have everything mounted in here, the power supply, the filter coming in, everything else that I need to mount in there, the driver and all that is all going to be mounted in that box. And that's going to be, I already have one box behind the lathe from the variable frequency drive. So I got to, hopefully it's not too crowded. I could mount it under the table. Sorry about the compressor in the background. Of course, it has to kick on as soon as I walk in here. But let me just finish swapping this back out. See, I made that motor mount on top. That one I did myself. I'll show you. I just got a coupling with a little bit of flex in it, and I made it go right to the threaded part on the back of the lathe, and the coupling goes right onto that. I actually had to bore it out to be exactly that size, as well as for the size of the shaft on that motor, because these motors have 5/8 inch or 16 and change millimeter shafts. They're big shafts. So, you know, the biggest I could find was 14 millimeter, which wasn't big enough. So I had to bore it out, which my lathe is running incredibly well. I did a lot of modifications to it, along with the new chuck, and I got an extension for the tailstock, which I've been wanting to do for a long time, because a lot of times when I'm drilling, I want to be able to get closer, or even when I'm milling, I want to be able to hold it from further back so that I'm not in the way of what I'm trying to cut. Oh, you're a little pain in my ass. There we go. Now are you all, hold on, I gotta take this off real quick. Because that, now that I'm pushing that in, I always had this in first before I shut it, which is what I obviously need to do, because if not, these things want to disconnect on the way in, because the wires are pretty tight. I put heavier gauge, not heavier, like pretty heavy gauge wire on it, because that's what it has on it already, the motor, and so that's obviously what it calls for. So I just put the same heavy gauge wire, but I did a four wire that was already wrapped, you know, so that it's got a sheathing over the whole wire. But so this is the sheathing for the 4-wire, but there are these heavy gauge wires right there. So you see, this is the 2 boards in here. It's got the 2 separate boards. So one is a driver and one is a controller, but they come together, and this is $25 on Amazon. So you can't beat it, really. I mean, generally you'll pay $25 for the driver and another 10 or 15 for the controller, or you know, you'll pay probably $35 for the driver for a NEMA 34, or maybe even, I think I paid 50 for a driver for this. Thank you. Yeah, I think I paid 50 for a driver for this, but you know, with this it's not necessary. It works totally fine with this. I'll show you right now. All right, let's see. I don't even need to turn the mill on. I'll just show you. This is how I was drilling the holes. I used my right angle drill to drill the holes for the motor mount up top. Oh, and the guy Greg from Priest Tools, the owner of Priest Tools, emailed me back finally, and his father was in the hospital, and some, you know, there was a good reason why he didn't get back to me, and I felt so bad. I was like, you know what, I won't return it. I'll use it. And I told him I had already done this, and I'm probably going to take this off and use his, just because I'm not the kind of guy that's going to return it over him taking care of his father. That's I'm not heartless. I mean, that's the bottom line. I can't. I mean, this shit. My mother's got cancer right now. If I can't understand that, then I'm a cold motherfucker. But I'm not. Okay, so let's see. What the hell? What the hell is going on? Oh, something didn't connect right. You son of a bitch. There we go. Yeah, something was loose. So that's counterclockwise and then clockwise. But it works pretty darn good for a small driver that's already installed on this board like that. I mean, I was testing because with this driver, because I didn't have another one yet, but I ordered 3 more because I figured I was going to use one for this, and then I knew I was going to have a couple extra stepper motors from this project, because I ordered several different ones, and there's a couple that are going to get returned, and I'm going to keep a couple of them. I'm going to keep the couple of bigger ones that I'm not using, because I know I'll have a purpose for those in the future. I just don't know what yet, but you know, there'll definitely be a purpose for sure. But after drilling, tapping, and mounting that, I'm going to end up taking it off and putting his on, because I don't have the heart to return it after that kind of a reason why he wasn't getting back to me. But anyways, oh, and then I actually did this. I was so tired of when I used the MR1, I had to crawl behind, bend down behind the machine to get to the power switch that's on. I don't know why there's an emergency switch on this electrical box, because I don't know who mounts it all the way up front, so you could be like stomping into it and all that. But I mounted it back there, so the e-stop was never any good to me. But also the power switch was all the way behind it, and as well as for the 120 volt. So I put this for the 220 and this for the 110. So boom, boom, everything's on. So that was a very worthy investment. I actually bought several of those extra to put on other equipment, because you know, it's always nice to have the power switch right there, because honestly it's a pain in the neck to have to go and crawl back there to get it turned on. But now it's nice and easy. It's right there. The 210 and the 220 and the 110 are right there, or really the 120 and the 240 are right there. And then the lathe has, I don't have really much of the other system left assembled, the other lead screw setup assembled, because I've already known for a while I wasn't going to be sticking with it. So that's the control box right there for it. Oh, you don't see it. It's hanging down, this thing. This thing was really junk. It really was junk. And then this is the encoder that came with it. This is the other encoder that I plan on using. This is the encoder that I got. This was actually kind of expensive, because I read that the higher resolution, which obviously makes sense. This is a 2000 pulse per revolution. So this is a good one. This was like $70, and a lot of them are like $20. The one that he used that I ordered was like $35, I think. So in case you guys are curious about pricing, this is the one that came with that setup, which was 1,000. Is 1,000 pulse per revolution, and his was 1024. So it wasn't much of a difference. Honestly, they didn't send a bad encoder, but the stepper motor is way underpowered. The interface is horrible. It's just not a good set. So and this box will close. It did close, but I'm going to obviously my cutout job was not all that immaculate, but I don't care. It's a workshop. You know, it's not meant to be pretty. It's meant to function. That's why, like with the screen and the touch screen versus the little buttons that he put on there, I think he made the right call, because I don't give a shit about having a touchscreen here. The DRO having an LCD is not a touchscreen, but I like the LCD because it has more functionality than a DRO like this. That's why, not because of, it's because of functionality, just like everything else I'm saying. You know, functionality is the primary concern to me. So this doesn't have a whole lot of functionality. I mean, it does have some functions and features. It's just not like that LCD one has a ton more that you can do. Like, I mean, this does have, you can make circles on this. You could do radius, yeah, you could do circles, but it's just much more clear and much more functionally. It's much more functional. I don't know where I was going with that. It's much more functional to me. So, and I'm sure most of you would agree when you see it, so, and you will see it soon. So I'll show you when I get it. But that switch I'm going to be taking back out because this DIN rail mount power supply is coming out. Over there, I'm not. So he's got another power supply that comes in the kit. I probably will just use that power supply for something else and just wire that also to the 48 volt. I mean the 24 volt DIN rail mount. I have Meanwell power supplies that are DIN rail mounted in here and over there. So that one that's over there, I can put a second output going to the Z-axis for his rather than for mine when I get it in and mount it. And then this one I'm going to take out because I'm going to put that other enclosure probably, it's probably going to go right down here. I'm going to mount it to the lip of the table over here, so that it's, or maybe to the back, that back piece right there, because I want it to be like kind of close, that if I need to get in it and do something I can, but I don't have really much room on that wall, obviously. But this thing is running great, and this this AccuSize 6-inch chuck is amazing. This thing is running amazing, so smooth. That noise is because that's the wrong belt. I actually got the right belt in today, and I'm going to be putting it on. I'm going to be putting it on in a little bit, but I did get the right belt in and a new pulley for the main drive, because the main drive is no longer using the timing belt. There was a timing belt going to this pulley, which this pulley I'm just going to completely remove because it's not going to be used anymore. There's no belt switching anymore. I'm just going to keep this pulley on, and then the pulley can move down the shaft, because this is a big shaft. This is a 3 horsepower A.O. Smith 3-phase motor. And I did that with, I have 3-phase power here, so I didn't have to change anything with the variable frequency drive. It's just the 3-phase to 3-phase. But this belt is a little too small in length, and it's too wide in diameter. So that's why it's making that noise. But it's still running really smooth. But when I change the belt, it'll be running perfect. And the pulley, I just got a new pulley because I wanted a new pulley on it. That's exactly the right size. But anyways, also the keyway brooch, I'm eager to make a new keyway, so that's going to be cool. So anyways, I'm going to get back to work on that lead screw, that electronic lead screw, and I will bring you guys back when I make some progress or get to a point that's worth showing, and or to a part of it that's worth showing how to do. And I'll either show you how to do it or show you how I did it. So, oh, and this is, if I do use the NEMA 34 servo, this is the motor mount that I got for it. So it's got full open access on the side for the belt, and this will mount wherever I decide to mount it. But I'm thinking about using, I've seen multiple people do the encoder with one of the gears, and put one gear on the shaft where it was, and then do one, like the gear on the encoder going to the gear on the lathe. So I think I may actually do that, but then I have to do the gear reduction for that if I don't do a 1-to-1 gear, which I probably won't be able to fit a 1-to-1 gear. So I probably would rather do a 1-to-1 pulley and belt, because then I don't have to figure another calculation into all of it. And these are the power supplies that I was talking about. Those are the 60 volt is on top, and the 48 volt, that's the very high amperage. It's 48 volt. Oh, it's a 48 volt. Is it 20 amp? I thought it was higher than that. That was a really expensive power supply. This one is a 10 amp, 60 volt. So I thought it was higher than that. I have one that's 65 amp in my workshop. I actually have another one. I have one that's 50 and one that's 60. Oh, that's the 50 that I was talking about. I didn't bring that one in here. Anyways, I will, when I decide what I'm using, I'll let you guys know for sure, like everything that I used. So if you guys are interested in doing this, I mean, obviously it's not my software, it's not my project. This is the guy from Clough 42 deserves all the credit here. He did this, he made this whole thing, and he shared it with everybody, and also the X drive, I'm going to share that in the description, but got to give credit where it's due. So it's not due to me. I'm just showing you guys how I'm doing it for myself. So that's that. Anyways, guys, have a great day, and I appreciate all of you as always, and I will see you guys soon. Be back when this is almost ready. Later. What's going on, guys? Chris here. So I just was about to start recording this, and I got a notification that I had a delivery, and I just got my Quill DRO, the new Quill DRO that I'm going to install on my mill, and I got one of my digital readouts, the LCD digital readouts. This is going to be for the lathe, even though it was supposed to be a 2-axis, and they sent me a 3. I believe. Oh no, that's not the Z-axis. This is for this other cable, which I don't know what it goes to. Here's the other wire. Right here. I don't know what this one goes to. This is to a sensor for some. Oh, this is for speed. I don't need that anymore. I think that's for speed. I'll have to read the manual, but anyways, I got the 2 DROs and a couple of gears. I ordered some different gears because I actually got a NEMA 34 servo, and I ended up using the Easy Servo, the same one that James did from Clough 42, who designed this. And I sent him a message on eBay where I bought the kit. Like how amazing I think it is that he shares his knowledge and intelligence. He's an incredibly intelligent guy. This thing worked, like, as soon as I programmed it and hooked everything up, just worked. It just works. I'm going to show you right now. I turn the encoder, the motor turns, and the motor's got a lot of torque, and now I kind of understand why I mean, I got to see it on the lathe, but I don't see why it would be, you know, a problem if he's using it on his. My lathe is very similar. So anyways, here's the setup that I made. I'll show you. This is the switch that I'm going to put on the front of the lathe. It's a typical momentary switch. So now everything's on. You see it lit up, Clough 42. And everything's already programmed. I did all the electronics last night. I programmed the board. I did this enclosure, and I wired everything nice the way that I would want it, and I can tolerate it. The plug is not that long because I don't need it any longer than that, and I wanted a heavy gauge wire. So I'm going to just turn it around and flip it up so you can see what I did in here. So I have the power going in right to a filter and to a ground. So everything goes to a ground, and then the filter is for electromagnetic noise, and then it goes to the power supply, which the power supply then goes out. I put a cable raceway in there so it kind of cleans it up. And then I put the, so coming out of the power goes to, this is a buck converter for the 5 volt, and then that goes to the board. And then it also goes to the servo motor, and it goes to the 24 volt fan. So I put a fan in the box just to keep all the electronics cool. And here we can change our feed numbers and whatnot. And let's see, feed and thread. I can do thread. It's on feed right now, but let's turn up the feed rate. I guess I have to hit it each time. If you hold it, it doesn't go up. I guess not. Let's just push it. I have a box printing for it because I was going to just design one, and then I thought about it, and he used a bud box, which should be relatively easy to find. Why is that doing that? There must be a connection that's losing connection when I... There we go. Just need to be pushed in a little bit more. I've taken it apart and put it back together a bunch of times in the last, 20 24 hours. I just built this last night. I just put the whole enclosure together and wired everything. So mine is a 2000 pulse per revolution encoder. It's not this. I have the same one that he used because I would revert to it if this didn't work. But when you download the programming, all you have to do is just change the numbers, and it's actually a much higher number. It's like 5400 pulses because it's complicated. But at least he explained it in the video on how to program it. And I don't have anything on here so you can see it turning, but you know what, let me put a piece of tape on there or something so you can see it. Hold on one sec. And now everything is done. All I have to do is go back there, plug this in, mount the box, then plug it in and mount the switch, and then mount the stepper or the servo and the encoder, and it's done. It's ready to roll. So I'm gonna go start doing that. I'm eager to see it work on the lathe. All right, so there's for that. Let's see. See, it's pretty immediate. Like there's really no hesitation at all. And that thing is aggressively strong. That servo motor is. Yeah, you guys can see it. It's aggressively strong. That servo motor is impressively strong. It really is. See, and then you have the speedometer right there. It's telling you how many RPMs. Which the only reason it's telling you that accurately in such a short distance, it's not even a full rotation, is because, well, I mean, the 1024 is probably still pretty high resolution, but obviously 2000, I mean, they go up to even higher than this. You can get them even higher resolution. I think like 30 something hundred or 5,000. They were like $100. This was like 60. But I mean, this is an important part, so I figured it's worth it to get a really good one. Yeah, see how fast it's getting the speeds? I mean, it's like not even a full rotation. It's getting that accurate. It's getting, 415 for 1 second where I just turned it real quick. But like, see, real quick, 402, 301. It's very precise, the encoder, which is what I wanted. And then the stepper is like really, I mean, the servo is really keeping up. Every time I move it, it's right there. I mean, I don't think there's more than a couple microsecond delay. What does it say? Reset. Oh, I went too fast. Oh, that's the thing. It has a maximum speed of 3,000 RPM. I don't know if that's going to be. Well, I have the feed on pretty fast too. I probably won't need it on that fast. Oh, I have it on thread. I mean, that was as fast as it goes, so I don't think I'm going to need it that fast. But yeah, generally it's moving slower than the spindle anyway, so. But the encoder is going to go as fast as my spindle does, which is pretty fast. I mean, my spindle, it's got a direct belt right off the motor from a 3 horsepower, 3-phase A.O. Smith motor. So I've clocked it at 5,500 RPMs. So, I mean, I don't like to run it that fast. It's kind of freaking scary running it that quick because it's got a 6-inch chuck on it right now. And then when the 8-inch is on there, that's going to be really scary. But I'm very happy with this, and honestly, I couldn't recommend this stuff higher from this guy. He's incredibly intelligent. You can tell in his videos, but he really mastered this thing. He really did. This like, even the kit that you saw me buy, if I put that part of the video in, I bought another lead screw kit, electronic lead screw kit, but I ordered his electronics at the same time. I was going to try to use the rest of the kit, because it came with the motor mount and the encoder and all that stuff, and it turned out that it was so bad. The stepper was so underpowered. Like there was nothing good in it. Like not just the electronics that I was never planning on using. There was no good parts in it. It wasn't even. There was nothing to keep. So I initiated the return. They're already trying to compensate me $20 to keep a $350 set. Like, are you kidding me? I don't know why these people think that's realistic. I said, offer me $250, maybe I'll keep it for $100. For what's in here, that's about what it's worth. I mean, the stepper motor's garbage. It's not even. I think the stepper motor is actually bad because it's like so powerless I can't believe that a NEMA 23 would be would struggle that much just to turn a lead screw. It's like it can't do it. I should put that section of the video in the beginning where you can see the other lead screw, because it literally struggles that bad that it can't even turn it at some points. Like once I reach a certain speed and it misses steps, it just stops and it like can't keep up at all. It doesn't move at all. So anyways, it's pretty pathetic. So don't order pre-made lead screw kits on eBay. That's one thing to take from that experience. And please take it from it, because it's that bad. And anyways, I do have, this is the encoder that I got that is the same one that he used. So if you wanted to use the same stuff that he uses, this is it's called Omron, OMRON is the brand, and the model number is E6B2-